Hi everyone, welcome to an update on Kwyll. This is a bit of a different one this time. I will be doing a usual development update later, probably in the next couple of days, with a few changes. Apologies for the delay in getting a new version out, or a new update out. I've been a bit down with some sort of virus or something, but slowly recovering. So also if my voice breaks or causes any problems all the way through, I do apologise for that. This particular video I'd like to do a bit more of a deep dive into some of the logic aspects, something I haven't done on any of the other videos. I've touched on it and I've explained a lot about how existing node graphs and node networks in the example project work, but I haven't taken the time to go into how you actually author new create new behaviors within the logic editor. This is prompted by a challenge I set myself recently, just as I was trying to find something to do when I was feeling a little bit better, to try and come up with something a little bit more interesting than just the character moving around in the rooms that you'd have seen in the other videos. I wanted to try and see if using the logic that's already there, largely without putting too much work into adding new nodes at this point, whether it would be possible to actually do something like a simple platformer type player controller, so jumping and landing on platforms and moving left and right, Manic Miner style, hence the graphic. Turns out it wasn't. That not the fault of the logic. The logic is pretty, although it's very, very simple building blocks, when used properly they can do quite a lot, even though you end up with quite a dense graph. More dense than is ideal, but I'll get into that later. But there were some problems with the collision detection that meant it was very difficult to do what I wanted to do. So I've made some changes to the collision detection, in particular the most recent changes to the collision, the most recent collision detection system that includes the painting of collision blocks on the tile map. See the previous video, I'll link it below for anyone who wants to catch up on that. So I made some changes there, nothing major, but just the way that it detects collisions in certain orders, which means you can do things like sliding before, as soon as you hit any part of a collidable tile in the tile map, it would just stop all movement, so you couldn't actually move down and along, or you couldn't move up and down while bouncing off a left wall. It would just stop you. So I've made some changes to make that a little bit better, and that was in support of this. But otherwise the logic seems to be doable. I'm going to try and do this as I say, as a bit of like a tutorial or a live coding demo, whatever you want to call it, just how I went through building this the first time through. I've got some notes, so hopefully I'll get it reasonably close without too many silly mistakes, but I am going to try and do this with minimum editing, just as I go through and as I do it, with all the mistakes and silliness that goes through, that shows up as I do it, so you get a feel for what it feels like to actually author something in the logic editor. So a quick status update of where I've created this project slightly differently, or based on the original, but modified to support this tutorial. So the logic is a little simplified over the standard player. It's only got left and right, everything else is the same. You've got the facing variable and the direction variable are as before, and it does the usual stuff. So it does checking left and right keys, changing the direction accordingly, move the object. It does the collision with the portal objects, and it does the animation change based on which direction you're facing. That's basically it. So if we go to the preview, I've changed the rooms a little bit as well, obviously, to make a platformer style game a little bit more viable. So you can see we can move left and right, collision works as normal, but up and down does nothing now, space does nothing, so that's all you can do, move left and right. So we'll work from here. The variables over here have changed from the original just to contain the two that are existing. So if we start start thinking about what needs to be done to do a jump. So the jump is the most important part, obviously. So what I want to do is I want to try and do something very similar to the manic miner jump. So I'm not going to be getting into complexities like parabolic curves and stuff. It's all going to be pretty hard coded, simple up and down over a period of time. So I think the way to do that is to start off by triggering a counter. So the jump takes place over a number of frames, however many frames I want to go up and then back down again. So the first thing I'm going to need is that counter that goes up and down and is triggered by hitting the jump key. So the first thing to do is to add a new variable, which we'll call the jump counter. I won't put a space in because I'm not sure how it deals with spaces. So we've got jump counter now. I should probably initialize that. So let's first of all put a simple set variable to 0 in the initialize flow. One of the things I do plan to do, just as a slight aside, is I'm going to enhance this to have default values for the variables, so we won't need to do this sort of setup. You can just set them up in there. But for now, that's the safest thing to do. So what I'm visualizing for this is the variable jump counter. If it's 0, then we're not jumping. If it's greater than 0, then we're mid jump, and if it goes beyond a certain limit, then the jump is complete and can be reset to 0. So we won't touch anything of this part of the flow at the moment. We'll create an entirely new flow down here as an always trigger, which will so what we need to do is first of all check if the jump counter, if we're already in a jump. So we want an int comparison, so we put an int comparison in, and we'll get the variable value for jump counter. Now if jump counter is if it's less than or equal to 0, probably zeros. If it equal to 0 would probably do, but less than or equal to 0 is usually a little bit safer. So if it's less than or equal to 0, then that means we're not jumping. So that means we are able to jump if we want to. That's the logic I'm following here. So the true path out of here is we're not jumping, therefore we're able to jump. So the next thing to check is, are you pressing the jump button? So we'll bring a new controller input node here. I'm not going to use the jump and fire button just because I prefer the up button for jump for this particular demo. It's just easier when I'm playing, so but you can choose whatever you like. So we do another in comparison here to see the flow is going to go from the true. So if we're not jumping and up is not 0, that means we're not jumping and they've pressed the up button. Then we need to set our jump counter off counting. So the way to do that is going to be another set variable jump counter, and we'll set it to 1. So all that's going to do is when you jump, it'll set it to 1. So we can try this. It's not going to do much, but if I push up, it sets the jump counter to 1 and it just stays at 1. So that's all we're doing now. So if I push up, nothing else is going to change, but pushing up set that jump counter to 1. So the next thing we want to do is, as I say, the jump counter is going to count where we are in the jump in a number of steps. So the next thing to do is to increment that counter over its range, which we'll do in the false statement. So if the jump counter is greater than 0, that means we're in a jump. So then we do what the we do the steps we need to do to process the jump. So that's going to involve incrementing the jump counter. So we set the jump counter to the result of getting the jump counter and adding 1. So that would just every frame increase the jump counter while we're in the jump indefinitely. Now obviously we don't want it to go indefinitely. What we want to do is then, if the jump counter is beyond our upper limit, however many steps we decide the jump takes, then we reset it to 0, the jump is done. So we put another int comparison in the flow after the set, and the int comparison is going to be checking the jump counter, which we can grab from over here rather than getting another node. It will just read the value out, the new value. And I know because I've done this before, but I'm going to set the upper limit to 14. 14 steps for the jump is right. It is right for the sort of jump I'm going to do later in terms of pixel movements, and you'll see why when we get to that part of the tutorial. So that's if the jump counter is greater than 14, then we're going to set it to 0, which indicates that the jump has completed. So this should work. When you come in, if you're not jumping and the button is pressed, then we start jumping. If you come in and you are jumping, then we increment the jump counter repeatedly until it reaches greater than 14, and then set it back to 0. So if we have a quick look and see if this works. So now we've got jump counter 0, goes up to 14 and down. So every time we hit jump, that counter cycles through its number of steps. Not particularly exciting, but that's what I was expecting to see, so that's good. Now one thing you'll notice, that jump counter, if you can see it, goes through the full jump incredibly quickly. Which is going to be more like a bound than a jump. It's going to bounce up and down very, very quickly if I start implementing the jump based on that speed. So what we're going to need is to slow that down a little bit. So to do this, I'm going to introduce another variable. Ideally, what I'd have at some point, and this is on the roadmap, is to have always have a frame count control on it, or another node that allows you to only execute a subgraph based on a frame count. But at the moment we don't have that, so we work with what we've got. So we'll add a new counter, which is going to be our we'll call this jump frame, because it's only going to be used in the jump. We should also set this, I don't think it matters too much, but just to be complete and to keep everything consistent, we'll set jump frame to 0 at the start, so we're working from a known status. Now, to keep it separate from this so that it doesn't mess up the jump logic, and we keep all the jump and fall later logic nicely isolated, we'll set up an additional very simple always up here somewhere, which just increments that frame counter every frame. So this is just going to be a set math get jump frame add 1 into jump frame. So this just every frame through, it will set that to its value plus 1. So you're already seeing here where there's some serious potential for improving efficiency here. These 3 nodes could easily be replaced with a single node that just says increment a variable, or increment a variable by an amount. So these are all things I'm taking notice of as I do this, but you can see how the limited set of nodes we have means you end up with maybe a little bit more detail in the graphs than ideal, but there's room to improve that over time. So now what we're going to do is we're incrementing that every frame, and if I just quickly show that just to prove it, we should see, yeah, the jump frame just continues jumping up and down, continuing up every frame indefinitely. Now what we want to do is excuse me, in here when we're in jump, so this is the false path, we're in the jump part here, instead of just incrementing that jump counter immediately, what we actually want to do is only increment it every second or third frame. So the way to do that with this limited set of nodes is to replace that with an integer compare, and we're going to compare the value of jump frame to 1. So if it's greater than 1, then we've gone through a couple of frames, and if it's true, it is greater than 1, then we can set the jump frame back to 0 and do our jump counter increment. So that means, and because the false is empty, so if you come through and it's frame 0, it'll do nothing, frame 1 it'll do nothing, frame 2 it'll go through. So let's test to see if that works. So now it should jump a little slower, and the jump frame resets to 0 every step through the jump counter. And we can highlight that a little bit more by setting this value up a bit higher. So if we now preview with the frame skips higher, you can see the jump goes up much more, much easier to see. Okay, so now we've got a jump counter, and we've got a jump counter that works at a reasonable rate. So now we need to do the actual jump. So this is where we need to work out how much to move the player by each frame. Now this is where I'd already worked out the value of where are we, 14 here, that's relevant. So if this is basically saying, if we go back again and think about this is if it's 14, then stop the jump. So what we want to do now is, if it's not greater than 14, then we need to do something with the jump. So what we're going to do is we're going to introduce another variable, and this one's going to be jump offset, which is the Y offset to apply to the Y position to move the player up according to where the player is in the jump sequence, the 14 steps. So the simplest way to do this is actually to set the jump offset. When you do a jump, so if you remember back here, the first thing you do is set the jump count when the player has pressed the up button, is to set the jump counter to 1, which initiates the count from 1 to 13. But at this point, this is where we also want to now set the initial state of the jump offset. Now what I'm going to do is I'm going to set this to -6, I think. This is where my notes aren't sufficient, so I may have made a bit of a mistake there, but we'll correct it if we need to. So it starts off as -6. Now remember, on the coordinate system, minus in the Y is up, so it's going to move up by 6 pixels. And then what we want to do is each tick, which is every n frames of this jump flow, we want to increment the value of the jump offset. So it'll go -6, -5, 4, -4, -3, -2, -1, 0, and then it'll go 1, 2, 3, 4, 5, 6, which is the reason for the 13. 6 up, 1 at 0, 6 back down again, brings us back to where we started. And this will give not a parabolic jump, but something better than just a simple linear up and down. It goes up 6 and then 5, slows towards the top, holds on the 0 for one tick, and then comes back down again. That would be the theory. So all we need to do here as part of this for now is to set the jump offset to jump offset +1. So we'll just add another math node, and we'll increment jump offset by 1. So theoretically now I'm going to save this because we're quite a way in and I haven't saved yet, and that's bad practice. So I'm going to save this as tutorial 1-1 just in case. Now theoretically, if I run this now, what we should see is, as well as the jump frame going from 1 to 14 or 13 before it slips back to 0, when we do a jump, we should see the jump offset cycle from -6 through to 6. So if you keep an eye on the jump offset, it ends up 7, so we've got something not quite right there. But we'll come back and see that in a minute, see what it works like. I honestly can't remember whether it was 6 or 5, but I'm fine with that for now. So now the last bit we need to do for the jump itself is to actually move the player. Now you'll notice up here in the actual movement graph, we're just taking the Y position when we do a move object, so we're never moving it in Y. So we're going to need to change that, but what we want to do is we want the jump here to be in control of what the Y position ought to be. So we're going to introduce a new variable, which is Y pos, which is the desired Y position, and we're going to disconnect that, and instead we'll get the Y position and put that there. Now this one is important to initialize, because it has to be initialized to not 0 but the initial Y position, start Y position of the object, so that the very first time through the always loop it'll just leave it at the position that we initialized the object to. So with that in there, nothing should change. Let's just quickly check everything as normal, and the player starts at the right point. So now to do the jump, let me just think what we need to do here. So this is on the jump offset has been incremented. What we need to do is add some more in here. I'm thinking to set the Y position to the Y position. We want math, because we're going to add the new jump offset to our Y position. So we get the jump offset here and our previous Y position here. Now theoretically that should work. That should set the Y position, and then up here in the next frame it will read the Y position and move it up or down depending on where you are. So again, we'll save there, tutorial 1-2, and give it a go. There you go. Now we've got a problem. So what happened there? This is the beauty of the variables. We can watch what's going on here. So we've got the Y position at 144, which is the very top, or puts his feet at the very top of that cell. I'm happy with that. Now if we move up, that's fine. So why didn't that second jump work properly? Let me just have a quick look. Jump offset, yes, I remember. Right, so what we need to do, when the jump is complete and the jump counter is reset to 0, we need to set, I'm not sure whether we need to set the jump offset to 0, but it's probably good practice to do so. So we'll set the jump offset to 0, and then we need to set the Y position to the actual Y position. Now the reason for this mainly is that if you jump, for example, at a platform or something that you can jump onto, what you're going to want to do is, as it jumps up, it can't come all the way down. It stops at a point on the downward section of the jump before it reaches the base of the jump. So the Y position is indicating a different position to where the actual object is. So when the jump is complete, we put this into our Y position so that we know exactly where we are, and it takes into account if you've landed on a new platform or a higher thing. So if I've got this right, that should now work. There you go. So now we've got jumps. I'm not entirely sure why he doesn't jump high enough, but I'll get to that in a second. That seems to be good. So now what we need to do is work out why he's not jumping high enough. So let's have a look at that. He's going 6 minus 6 through. Seems to be going up enough, but it's not jumping. So let's think about this. Minus 6. 6 plus 5 is 11, plus 4 is 15. 3 is 18. It should be jumping plenty, so let's go and see why it's not jumping high enough there. What do we set the we set it to minus 6. Let's try setting it to minus 7 just to see what that does. That works. And the jump offset is setting to 0, but I'm going to disable that just for a moment, and I'll show you why. I'm going to in the jump complete, this one here, we set the jump offset to 0. I'm going to disable that for a moment because I want to see where it's ending up and see whether the counts are okay. So let's jump offset 6. Yeah, I think I've got the ones off a little bit. It's probably the order in which they're running. This is something I need to look into, but that's good because it's ending up where I want it to be. So we can jump up, we can land on platforms, but as you can see, we don't fall at the moment. So the next thing is to work out how we do falling. So ideally, what I'd like to have is some way of telling if an object can move in a certain direction, and it wouldn't be too troublesome to add a new node to do that, to check the collision, but I'm cautious about adding that because checking collision detection multiple times in a frame in a single logic pass can be quite expensive. So if we can avoid that, all the better. But for now, we don't have that anyway, so that's just not an option. So what I'm thinking here is, if we're not jumping, what we want to do is, if we're not jumping and the jump is complete, let's just wire this back up again before I forget. If you're not jumping and the jump is complete, then we're going to want to try and move down. I can't remember how I did this now. I'm going to save this and load the previous one where I've done this, and I'll be right back. Let's have a look, see what I did before. It's all normal. It was -7, so that's good. Bear with me a moment. I can't find in here what I did. We set yes, yes. So here, so in this section here, this is where if we're not jumping and we're not pushing jump, then we set variable ypos to ypos +1, which is down 1, which is basically always adding gravity when you're not jumping or in the middle of a jump. So we'll reproduce that in our test. Let me just quickly reload the previous one and see if we can remember where we were in here. So this is okay. So we've got that. So that is do a jump. Those two are do a jump, and this path is going to be what we just seen in there. So we're not doing a jump. We're not currently jumping, so let's add some gravity to our Y position. Get Y position and add 1. 1 being down in Y. So hopefully that should now. That wasn't supposed to happen. So what did it do? The Y position is continually running down. Now, I remember what I did here. So, and that's because the Y position is just continually going down, 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 but nothing's ever stopping it if it can't go down. So if it's on the ground. So this is where we need to change slightly the main routine. So this is where we've done a move, and this that I've just disconnected is just the update the animation direction. What we want to do is add a new step in here to set the Y position. We'll connect it to the move object, and it's going to set it to the Y position. So this will basically mean that it'll try to move to where it wants to. So down here, every frame we've added 1 for gravity. It will try to move down because gravity is forcing it to. The collision detection will prevent it moving down, so Y will remain where it is. And then here, just after that, it will set Y position, the actual Y position where you ended up, to the Y position that the move resulted in. So theoretically now we should have a stable position, and if we go and stand on our platform we fall off. So we can go up and down and off into here. The reason he fell through there is because foolishly I had forgotten to, and I hadn't added extra collision here. So the only way you can actually get out is to collide with this object over here, which means you actually go off the end for a bit. So just for safety, put some extra collisions there so that can't happen. That should solve that final problem. It doesn't. I'll come back to that one. That's not the purpose. The purpose of this tutorial was to show that we can do this simple manic minor style controller with fall, jump and platforms with the logic as it currently stands. Now, as I said, this isn't ideal. There's a lot more in here than we'd need, and if you think about it, things like that set of 3 could be collapsed to 1, that set of 3 could be collapsed to 1, just by adding a single new node that does an increment variable, or add to variable. And there's a lot of other things in here. So we've got some integer comparisons, that could be replaced with better solutions. The frame update, I'd like to have a built-in frame variable, and then maybe some additional math operations like modulo for frame control. But generally, that kind of work. So this could be wrapped up. This whole logic tree could be wrapped up into a once the grouping is working, into a packaged platform player controller type logic that you could then just drop into place and get a Manic Miner style controller player. Okay, so that kind of worked. Any comments, any thoughts on this, or any ideas? Please do make a comment below. Just one word: the people who have just recently gained access to this as part of the Coffee silver tier, this won't work in the version you have at the moment because of the changes I had to make to the collision detection. I'll be doing a new release and sending it your way, maybe in the next few days, by the weekend at the very latest, so you can play with this then. And this sample with the fully operational jumping controller will be part of the example data, so you can play with that as well. Anyone else who's interested in getting that early access, pop over to the Coffee site and subscribe. Everyone who subscribes to the silver tier will get automatic access, early access. I've also set up a Discord channel. I'll put a link in the comments in the description below. Anyone can join. Certain sections of it will be open only to people who subscribe, but the general stuff will be open to everyone. So it'll be a good place to start up some conversations and suggestions and ideas. And I'll see you next time.